here go deep underground and come out inside the house. This is part of the cooling system for the cooling and ventilation system for the home. This setup here, these are our 4 domes. This particular building will have a dome on each corner of the house, so 4 of them on this house. This one here is under construction currently. This is how we basically set up to do this. We have a predetermined height at the top. Each one of the bars are spaced out evenly on this, and then the rebar comes down to the bottom where we have a peg that are all set up at the same height, 22.5 degrees apart from one another, exactly the same distance from the center. That gives us a nice round half of a dome or a hemisphere.
You're doing it, man.
This material right here is EPDM. This is a rubber pond liner, and basically what it's here for is to, as you can see, it comes down from the top of the wall. This will waterproof the entire berm so that we don't have any moisture problems inside the house or anything with mold or anything such as that. It'll keep this whole entire piece of berm here dry and help to stabilize the temperature once it's covered over with earth on the outside. You can see on top the white. This is a super adobe bag. It is made out of polypropylene. It comes in a long tube. We basically take them and fill them up with earth, put them in place. This forms the rounded concrete wall forms for the bond beam on top of the tire wall. In here you can see that the walls are constructed out of tires. That's the Earthship concept there. Each one of these tires has almost 6 wheelbarrow loads of dirt compacted into it. So we've taken it and compacted it as tight as we can possibly get it in there. So these things are very, very compact. They weigh over 300 pounds each. And again, you can see the white adobe forms on top of it that will ultimately be the concrete form for the ring beam that remains in place. So it'll actually be a permanent part of the house. That way we're not wasting a bunch of plywood that we've made concrete forms out of. You can see in the walls here these tubes that are coming through. This is the other end of the tubes that we saw outside, and that's where basically fresh air comes in through that. It's drawn into these rooms here by each one of these rooms that has a dome roof on it has a large thermal chimney on top of it. That chimney gets heated up by the sun, and as the sun heats it up, the skylight on top of it, 4-foot by 4-foot skylight, is opened up. That allows that convective energy to rise up out of the thermal chimney, and as it does that, it creates a negative pressure inside the building and gently pulls the air that's been tempered by the earth where it passes through almost 22 feet deep near the edge of the house there. On top of this area here, this is our constructed wetlands in the center. This will actually be used to grow vegetables inside of it. We'll be growing tomatoes, bananas, peppers, things that are fruit-bearing plants. That, in combination with the gravel and sand that will ultimately completely fill this, is going to filter the water to a level where it's clean, and we'll use it at that point a third time to flush toilets. So we completely recycled all the captured rainwater that we use on here, primarily used for cooking, bathing, cleaning, etc. Anything you'd use for water usage inside your house. It's then recycled, filtered through this, and then reused for toilet flushing. On top of this area is going to be a large greenhouse roof, so the plants have plenty of sunlight to grow, and it'll also bring a lot of light into the space here. We'll have a lot of bottle brick walls on these interior walls here so that light can pass from the atrium area here into each one of the rooms. Pretty soon these beams that you see in place here are made out of papercrete. Pretty soon those will all be up, joined together, brought up to height with a small temporary form, and then we'll actually be pouring concrete inside of that to make the center support structure for the home.
I think that's good, man.
Here's our sewage treatment plant. Basically, this is a standard septic tank. You can see it's still exposed right here. Ultimately, we'll have a glazing system built over the top of this, a glass front on it to retain solar heat. The top of the tank will be painted black so that it actually absorbs more heat. What we'll be doing is heating this sewage to speed up the anaerobic digestion process. At that point, we can capture methane off of it, which can be used as a cooking fuel or a motor fuel. The secondary treatment, as you see right here, we have a setup where there's a three-way valve. Instead of going into a traditional drain field, which we can do if there is ever a problem with the constructed wetlands, we can change this valve to divert the flow into a standard drain field, so it would act at that point as a normal septic system. But what we'll be doing is dumping this effluent into another constructed wetland similar to what we saw inside. This one's a little bit deeper, and ultimately this will house plants that are very large tubers, starchy tubers, primarily cattails and duck potato in this instance, and those plants will help to uptake excess nutrients out of the soil, clean the water out of the water. It'll help to clean this water up again, and then the water will be clean enough to use for irrigation outside the home here. The plants that are grown inside of this are selected so that they have the largest rhizome possible, and those plants are then harvested and used to be converted into ethanol fuel. The byproduct of the ethanol production is a very nutrient-rich wort that can be composted and turned into a fertilizer for more plant production.
Perfect.